Hello, and welcome to Autology, the podcast that brings you the latest on automotive technology. I'm your host, Alicia Thakkalal, and today's episode is called An Electrifying Drive, the Next Phase of EV Propulsion Tech. Here with me today are Graham Evans, Director of Electrification Technology Research within S&P Global Mobility's Supply Chain Technology and Aftermarket Group, and Ben DeLand, Director of Electrical Hardware Engineering at GKN Automotive. Hello, and thank you for joining this episode of Autology.
Hello, Alicia. Thanks for having us.
Hi, Alicia. My pleasure to be here. Thank you.
Wonderful. Lovely to have you both. So, this podcast is all about the auto industry's fundamental shift to electrified vehicles, the technologies required to deliver this, and also the associated supply chain shifts that are currently underway. And then for the audience, with today's guest, we'll be providing some context on the pace of change as well as outlining some of the key technologies that are helping accelerate the shift to affordable mass market global EVs. So let's just jump into the first question. So, Graham, to start with, could you tell us a little bit about the scope and remit of the Electrification Technology Group at S&P? What your team covers and a bit about your background.
Yeah, absolutely. Thanks a lot, Alicia. Nice and brief. Yeah, I have the pleasure of leading a team of 18 analysts globally who are part of our supply chain technology group and then the wider S&P Global Mobility Planning Solutions Group. So this is everything forward-looking and in terms of how the car industry is evolving. Really, our objective as a team is to research the maintenance, the evolution of our forecast data sets around some of these critical technologies. So batteries, charging, propulsion, thermal management is the remit of our group. The nice thing about being at S&P Global, we're kind of technologically agnostic, really. In some respects, it doesn't matter if EVs thrive or whether diesel made a wild comeback, right? We want clients to rely on our data. We want them to trust our data. So that's our premise. That's our raison d'etre. And yeah, from my side, 7 years with the business now, a background in engineering. I used to work for OEMs here in the UK.
Wonderful. Great. Thanks for that overview. And Ben, could you please introduce yourself and, for those who are not so familiar, a bit about GKN Automotive?
Absolutely. So, Ben DeLand, I am Director of Electrical Hardware Engineering at GKN Automotive. And GKN Automotive, if you don't know them, we have a rich heritage in automotive that reaches back to the 1950s. And as a parent company, actually to the late 18th century, starting as an ironworks company in England. So, quite some history there. Currently, we supply 90% of the world's automotive OEMs with driveline and electric powertrain solutions, such as electric drive units, all-wheel drive systems, and drive shafts.
Okay, great. Thanks. That's wonderful. And so we have a good mix of the holistic market perspective as well as the business end of supplying key components. I expect this will get technical pretty quickly, but let's start with some industry perspective. Firstly, Graham, could you please outline your team's sort of forecast on the production of electrified vehicles and also its implications on EV tech development? So, for instance, like batteries.
Absolutely. Yeah, it'd be my pleasure. So let's maybe start with a think about EV uptake to date. So, in terms of our data from 2022, global battery electric vehicle production of around 8.4 million units. So, this is fully battery electric vehicles, not including hybrids, mild hybrids, full hybrids. This is purely battery electric. The forecast by 2030, we expect this number to be around 43 million. So this will represent some 45% of total vehicle production will be fully battery electric by 2030. So we're on this really rapid uptick. We have been to date, and we continue to 2030. Perhaps in the context of this discussion, it's fair to say that of those 43 million vehicles, all of those will require at least one e-axle or e-drive system, as we might say, and I would say a number of the plug-in hybrid applications will also require an e-axle. So this is a really significantly growing market in terms of, let's say, the demand for this technology and the vehicles that will be using them. Maybe a bit wider context around the EV space. This corresponding increase in electric vehicle, or this increase in electric vehicles has a corresponding increase in demand for batteries, going from somewhere around zero point 0.5 of a terawatt hour in 2022. We expect we're going to need about 3.3 terawatt hours of batteries by 2030. Within this, we also expect an increase in average battery capacity. So, of course, with concerns around all electric range, people want more range on their vehicle. We expect the average battery will increase in size from around 55 kilowatt hours now to around 74 kilowatt hours. And as you can imagine, the increase in demand for certain battery raw materials will necessitate a similar increase, obviously, depending on the chemistry. We expect demand for lithium to go from somewhere around 64.5 thousand tons to around 369,000 tons for all electrified models, pardon me. So for all of those mild hybrid, full hybrid EV applications, we're going to need some 369,000 tons of lithium. So huge ramp up and a huge shift in terms of commodities that are required to support this electric vehicles. This number doesn't include medium heavy duty. So perhaps thinking about the 6 tons and above market share would be above and beyond that. It doesn't include any kind of e-bike or two-wheeled applications or even three-wheeled applications for specific markets like India. And really, I mean, I think I often clarify this by saying, regrettably, there is no S&P Global Mobility crystal ball. In terms of where our data comes from, we ingest a lot of data. We actualize our data with solid, industry information coming from the major authorities. And then in terms of our forward-looking view, we employ, let's say, a combination of analyst primary and secondary research coupled with some data science in order to build these forecasts. And of course, there's a kind of top-down macroeconomic, geopolitical incentives and legislation-related view that meets the bottom-up research of who's working with whom, who's developing what technology, what's a given OEM strategy, et cetera, that we build into our forecasts.
Wonderful. Great. That was a great overview. And from what I take from it is that things are expected to change quite rapidly. Ben, from your perspective at GKN Automotive, how have you observed the shift to electrified powertrain today? And can you provide some context on how you see the next few years evolving?
Sure. So from the supplier side, we've seen a major shift in focus from our customers toward electric vehicle platforms over the past 2 to 3 years. The technology side, I think we see a rapid set of changes that are focused on easing the anxiety of consumers toward the shift toward electric vehicles. Those anxieties, I think, are largely around range and cost. So improving the range, as Graham had mentioned, battery capacity is one thing, but also efficiency of the vehicles. So ensuring that the energy that's in the battery can translate to torque and speed at the wheels in the most efficient way possible. So it's ensuring that you're getting the most use out of the batteries that you can possibly have. So that's been a focus. It's been a huge focus area for GKN Automotive as well. So efficiency is something that our customers are always harping on, always looking to improve going forward. I think evolving, we still need to work on the purchase cost here. So a major barrier for mass adoption in the way that Graham had mentioned is we haven't reached that cost parity between combustion engine vehicles and electric vehicles. So looking for further opportunities for cost down through packaging, through further integration of the powertrain. And I think also our customers are starting to look for some differentiation going forward. So how do they make their EV's driving experience unique for their specific consumer? So increased driving dynamics, increased safety measures. We talk about three things a lot: stability of the vehicle, agility of the vehicle, and traction. So our customers there are really trying to stand out for their consumers.
Okay, understood. Interesting. Sounds like you're gearing up well for the shifts that are taking place. And then, Graham, in terms of the critical technologies that you and the team are focused on from a research perspective, can you sort of outline what you see as the major opportunities as the industry evolves?
Yeah, sure, absolutely. So, I mean, obviously, huge shift. Naturally, there's technologies now that will be of less relevance in 5 to 10 years' time. But of course, there's new technologies where there's huge opportunity. I think the two key technological challenges that remain, as Ben alluded to as well, is one is certainly range, and the other is charging time. So how far can we go on a single charge? And then also how long does it take to charge? And these really feed into two associated challenges of cost. And then that is also kind of in part dictated by scale. So with increased scale of electric vehicles, the cost will come down. And of course, some of these technologies that are more high end right now, like the kind of really high power charging, will start to become a bit more common, a bit more commoditized. The hardware required to do that will come down in price, and therefore EVs will come down in price. So whilst the battery, of course, is the critical factor, there's a huge need for the technology associated with efficiency improvements in the above areas. So this could be the motors themselves. This could be the supporting power electronics that are delivering if you like, delivering the electricity to the motor fundamentally, and then the thermal management of all of the above. If we can run the vehicle in a more thermally optimized manner, we're going to get higher range, we're going to get lower losses, we're going to be able to use more of that energy in the battery. Typical engineering challenges remain: weight reduction, simplification, cost reduction. How can we build it on a production line to the desired level of quality? This doesn't go away, and indeed we have a major rethink of this because of the inherent structure and change of the electric vehicles. Lots of exciting and innovative technologies in the inverter space in order to improve efficiency and provide, let's say, sustained high performance. And obviously the high voltage architectures that I'm sure Ben can talk about, that GKN Automotive have very much of a presence in, these are critical to that. So the idea that high performance applications, you could drive it around the track 3 or 4 laps, and an EV might then be struggling to maintain that high performance. With these superior power electronics, we should have answers to these types of questions. And then the thermal management, technology like heat pumps that we see effectively displacing the incumbent electrical heaters. Let's remember, you don't have this big heat source under the bonnet anymore of the vehicle in order to be able to tap into and be able to heat the cabin. We have to find energy efficient ways to heat the cabin, but also in terms of keeping the right bits cool. Immersion cooling technology for batteries moving forward should be something that should help make sure that battery can remain in the optimum thermal management range at all times, which supports optimum range, be it winter or summer or cold climate or hot climate, and also ensure that losses can be minimized.
Understood. I mean, those were quite a few points. I mean, from your perspective, Ben, are you in agreement with Graham's assessment of the focus areas? But obviously, feel free to disagree. But we know that technologies for high voltage architectures are a big focus. Is that the case for your future development projects?
Yeah, so I do largely agree with Graham's points, but I would add a couple. So certainly efficiency and costs are the top level factors that are driving the technology innovations right now. So starting with efficiency, that can come in many of the ways that Graham had mentioned: better thermal management, more sophisticated software for controls to create more efficient power signals for your traction motor. The increased voltage is a really important part of efficiency as well. So when we look at power losses in an electric vehicle, the power formula in electrical terms is power equals current times voltage. But current is what is resulting in heat loss through the resistance in the cables and the motor and in the inverter. So if you look at the power that's being delivered and consider that it's current multiplied by voltage, if you increase that voltage, you can have the same power and reduce the current. So you can reduce the current linearly at the same scale as the voltage is increasing and deliver the same power, but that's resulting in less losses. So from vehicle electrical architectures, we've seen a shift from 400 volts to 800 volts to improve the efficiency overall of the powertrain in electric vehicles. And the interesting thing going forward will be if we see that trend continue upward toward a kilovolt or even slightly higher. Once you reach certain levels of voltage, there are some other challenges that you're running into regarding high voltage safety and arcing and these sorts of challenges where the physics are a bit too much to overcome. But that voltage increase that's ongoing right now is really critical to efficiency. The other point that I would add here, I think, is that there are a larger set of vehicles coming to the market that are different from the first generation of vehicles. So we're seeing more off-road vehicles here that have really different driving experience demands, higher torque, lower speed for these off-road conditions, the traction for off-road. There's some different challenges there. So what we're seeing is a lot of the functionality that you see from all-wheel drive in combustion engine vehicles making its way into electric vehicles in a bigger way. So that's a focus area, I think, for technology innovation in EVs as well.
Okay, understood. That's super interesting. Thanks for that. And then I also want to turn to the supply chain and touch upon the competitive landscape. And Graham, you've discussed on Autology before this sort of wrestle for ownership of the electrified propulsion landscape and the OEMs or car producers wanting to insource critical e-axle components. I mean, can you provide some context on that?
Yeah, absolutely. Would be glad to. So, I mean, really, in terms of how we see this space evolving, of course, there's this aspect of ownership of the powertrain, ownership of the systems that effectively are responsible for the propulsion of the vehicle, and historically speaking, around 90% of conventional engines have been manufactured by the car companies themselves. Only about 10% of engines have been manufactured, but of course the components that are used to make up those engines have largely come from the supply chain. So, in some respects, as the electric vehicle kind of revolution has taken off, the volumes of these electric vehicles have been comparatively low. The OEMs have been not necessarily that keen to perform all of the kind of system development in house of these electric vehicles. So, reliance on the supply chain has been quite heavy so far. We kind of defined this related to electric motors in two ways. The actual fundamental motor manufacture itself, so the assembly of the rotor stator, this is still something we see as typically the domain of the tier ones or sometimes even tier twos. But then what we call system integration, so taking this motor assembly and integrating it into a vehicle ready assembly, an e-axle. So if we take a look at our data, I mean, in 2022, we see that for the motor, around 48% of motors are produced in house. We see vehicles like the Audi e-tron, for example. Audi are doing the winding of the motor themselves. When it comes to something like system integration, we see in 2022 about 70% of the system integration is done by the OEMs. So about 30% of the wider integration is done by tier one suppliers. When we move to 2029, we see a slight increase in the amount of motor assembly being done in-house, about 50-50. But in the terms of the system integration, we see about 74% of e-axle applications will be integrated by the OEMs themselves. And there's several reasons behind this shift. Of course, the OEMs now, with increased scale, when battery electric vehicles become more normalized, they want to take a degree of responsibility for the packaging of that assembly into their own vehicle. There's another element of this around, fundamentally around ensuring the margins on their vehicles and, of course, jobs. These OEMs have a large number of people currently employed in the assembly of conventional powertrains, of engines, and in some cases transmissions. And of course, they want to put these people to work on the powertrain of the future, and that fundamentally, from our data, is set to be e-axles. So it's not to say that the expertise of the tier ones is clear. Many of them have already demonstrated their ability to deliver e-axle applications, and it's a very competitive landscape. And of course, opportunities exist further down the supply chain around, let's say, the rotor stator technology. This is really critical. It's where a lot of efficiency improvements are coming from, and we expect this to largely remain the domain of suppliers given their expertise. We have some new research coming along to support this, which we'll be glad to share in a future podcast.
Okay, understood. Thank you. And what are your thoughts on this, Ben? I mean, can you comment on just how competitive the space is at the moment, or how GKN Automotive is set up to establish its presence in this area? Perhaps to put it another way, what distinguishes your technology from your competitors or the OEMs who have chosen to vertically integrate this technology?
Sure, yeah, would be happy to. So to address the competitiveness question first, So we have, I think, in the first generation of EVs, seen a lot of insourcing at OEMs for the reasons that Graham had mentioned. I think I would add that with any new technology, the auto manufacturers need to become experts in that technology before they can effectively manage a supply base. And right now, in this transformation that's happening in the industry with electrification, that is a key technology that OEMs are getting right. It's the major driving force behind their vehicles right now. If that technology focus shifts in the future toward autonomous driving or don't know what else, then I think you can also see that engineering focus on their side shift. But otherwise, in competitiveness at the supply base, I think you see the suppliers of combustion engine components, engines and transmissions, they really need to shift their business over toward electric drive systems or die. It's really critical for them to do that, and they're willing to take business at low margins to transfer that business over. And then, if we are honest with ourselves, we could say, well, it's by no means trivial. Electric drive units are much more simple and less capital intensive than developing combustion engine powertrains. That's inviting more players to the arena within the supply base. So, from GKN side, how do we look at that? Well, I think we go back to our DNA. We are having 25 years of experience providing all-wheel drive systems, helping our customers integrate at the vehicle, the drive line, from the transmission output all the way out to the wheels. We have vehicle integration experience that is valuable for our customers. Driving dynamics is right in our wheelhouse there. So if we look at the first generation, if we call it a first generation of EVs, I think the focus was on longitudinal dynamics, going fast, having a lot of power. In this next generation, we see more of a shift toward lateral dynamics, where these all-wheel drive type functionalities are integrated into the electric powertrains. And that really is where GKN Automotive shines. It's where our experience is, and it's where we see our opportunities going forward.
Understood. Thank you. Thanks for your perspective on that. That's really wonderful. And perhaps for a final word, we'll start with you, Ben. It'll be good to know, what are you most excited about in the next 5 or so years of this EV transition?
Yeah, it's a really exciting time to be working in engineering in this field. If we think about combustion engines, they've been developed for 100 years or so, where the past 20 years or so, how many innovations of major scale have been made in combustion engines, right? The technology has consolidated toward the most effective one. With electric drive systems, we've been developing them for 20 years, and really only in the past 5 years with some engineering scale behind it. The market is still consolidating toward a technology that is considered the best or the most efficient. So right now, there's a ton of innovation in the space. The technology is changing rapidly. And I think we have a really great opportunity to further improve efficiency, further improve cost. The thing I'm passionate about would be improving the efficiency to a level where it's just so black and white clear regarding things like sustainability and cost of ownership, where the option for the consumer, the choice for the consumer is just so clear that electric vehicles are the future and are outperforming combustion engine vehicles in almost every way. So it's a really exciting time to be in this space.
Understood. And just to add to that, do you see that sort of cost parity coming within the next 5 to 10 years?
Personally, I do. I think so. The reasons that Graham had mentioned regarding scale. So some of the initial capital expenditures are maturing from our customers, that they're not passed down to the consumer as much. So we see the cost down there, but also on the technology side, there's been a lot of work and continues to be a lot of work to reduce costs in the systems through integration in the electric drive units, through better packaging, weight reduction, new technologies coming into the inverter. So I honestly do see that in the next 5 to 10 years.
Wonderful, great. And then what about yourself, Graham? What are you most excited to see in the next 5 years?
It's a great question, Alicia. Thanks a lot. I mean, I think the transition to cleaner transportation is in itself inherently exciting. I'm a city dweller. I live in London. I'm not going to complain about breathing cleaner air. Absolutely, and obviously two aspects to the vehicle in terms of its emissions. One is carbon dioxide emissions through burning fossil fuels, but the other is the tailpipe emissions. And of course, we wipe out the tailpipe emissions at a stroke when we drive an EV. I think the question around whether this is exciting or not, I think Formula E has proven it can be exciting. So for anyone who's been and attended a race, I would say, okay, you miss out on some of the sound and some of the drama, but it's great racing. It's very competitive, and it's proven that these can be high performance vehicles, certainly. On the topic of noise, I mean, I'm a former noise and vibration engineer. That was how I cut my teeth in the automotive industry. EVs are a fundamental improvement. There's no two ways about it in terms of their refinement, in terms of their driving experience, and let's say the occupant comfort. So, and the pace of optimization here is so fast. The rate at which electric vehicles are improving. This will drive down some of the cost that we talked about and help us get towards that cost parity. Certainly, challenges around, let's say, the cost of domestic and electricity may further strain the consideration in terms of running costs. But absolutely, we're in terms of the vehicles, there's more choice, there's more EVs coming to market. You think about 10 years ago, the options were so limited and so inherently flawed in terms of their range and their ability to charge. Right now, not many people would turn down a Porsche Taycan, and that's a 5-year-old car now. So obviously, new developments coming down the track from OEMs. It's a really exciting time to be in this industry.
It certainly is. Great, thank you. Unfortunately, that's all we have time for today. A big thank you to you, Graham, and to you, Ben, for joining Autology and sharing your insights.
Thank you, Alicia. Yeah, thanks for having us.
Thanks, Alicia. Had a great time.
And thank you to all you listeners for tuning in as well. We'd love to hear your thoughts on today's episode at our autology@spglobal.com email. And you can find out much more at autotechinsight.ihsmarket.com. Don't forget to hit all the subscribe, follow, and like buttons to stay on track with the latest Autology news. And we look forward to you joining us in the next episode. Bye for now.